All right, today's lesson is on topic 4, classifying elements in our mix and flow of matter unit. And we're going to start by talking about element symbols. So if you look at this diagram here, you'll see the ancient symbols that were used in the past. So they were like diagrams or pictures of elements. The modern method of showing elements using symbols is with letters. So when we look at our element symbols in our periodic table, so on the right here we have our image of a periodic table, you'll notice that the element symbols are one or more letters used to represent the name of a substance. So for example, O, capital O is the symbol for oxygen, and we'll find it right here. That is oxygen. N represents nitrogen, C represents carbon, B represents boron, and so on. Some of the elements you'll notice have two letters. The first will be a capital and the second will be a lowercase. So for example, Fe here represents iron. So capital letter, lowercase letter. For zinc, it's represented as Zn. Again, capital and then lowercase. All right, so it is important to kind of get familiar with the periodic table, especially the first 20 elements, to be familiar where they are on the periodic table. So there are different kinds of elements, and the elements are classified as metals, nonmetals, and metalloids. So we'll talk about that a little bit more. Metals, these are elements that are able to conduct electricity and heat. They can be hammered into sheets, which is called malleability. You can stretch them into wires. That is what ductility means. They usually have a shiny appearance or luster, and they are all solids at room temperature except for mercury. Mercury is a liquid at room temperature. And if we go back here, mercury is represented by capital H, lowercase g. And if we look for it on the periodic table, it is right here. All right, so those are some properties of metals. Next, we'll talk about nonmetals. So nonmetals at room temperature, they can be either gas or solid or liquid. So for example, there is only one that's liquid at room temperature, that's bromine. The rest are either gases or solids. The solids are usually brittle. They cannot be stretched into wires. They're not shiny, and they do not conduct electricity or heat very well. And then we have the metalloids. These are in between metals and nonmetals. So their properties are going to be in between metals and nonmetals. So they can have properties of both metals and nonmetals. For example, silicon, it's the only metalloid found among the principal elements in Earth's crust, and there's only a few metalloids. So if we look at, oh wait, I just have a chart here. This chart is just a summary of the properties of metals, nonmetals, and metalloids. So again, metals, their state at room temperature, they're solids except for mercury, which is a liquid. They're shiny, they have luster, they're good conductors of heat and electricity, they're malleable and ductile. Nonmetals, there's some gases, some solids, bromine is liquid, they're not very shiny, they're poor conductors of heat and electricity, they're brittle, they're not ductile. And then metalloids, like we talked about, they're those in-between ones, usually solids. They can be shiny or dull. They may conduct electricity. They're poor conductors of heat. They're brittle and not ductile. So if we look at this periodic table here, the first thing to note is this staircase, this black staircase. That's what it is called. That staircase is splitting metals and nonmetals. So if we look here on the left side of the staircase in red, these are all our metals. On the right side of the staircase in blue, we see the nonmetals. And notice here, this is hydrogen. It is also a nonmetal. And then in yellow, we have some of those metalloids. Okay, so next we are going to start talking about chemical families. So chemical families on the periodic table, they're also called groups. Okay, so it's either going to be called a family or it will be called a group. And the definition of a chemical family is they are a group of related elements and they have similar properties. So for example, in the past, gold, silver, and copper were once used to make coins, and they were referred to as coinage metals. But now, if we take a look at our periodic table, we'll notice how here, Cu, that's copper, Ag and Au here, representing. So the first chemical family we're going to look at, or the chemical group, are the alkali metals. So these are the group one chemical family. So if we just move over to this slide here, you'll notice groups are shown as columns. So here's group 1, group 2, 3, 4, 5, all the way to group 18 here on the end. All right, so the first one we're talking about is group 1, which are all of these. These are the alkali metals, not including the hydrogen. So this light tan color represents the alkali metals. So these alkali metals, which are group 1, they're very, very reactive metals. And the reason being is they have an unpaired electron so that they are willing to form compounds. So the ones that are included for the alkali metals, that's lithium, represented by Li, sodium, which is Na, potassium by K, rubidium is Rb, cesium Cs, and francium Fr. So if we look at these diagrams here, this example here, we have freshly cut sodium. It's bright and shiny, but only while stored in oil. So the liquid here is oil. If we expose sodium to air, after a few minutes exposure, the surface gets dull because the sodium atoms react with oxygen in the air. And then here we have sodium as well. If we take sodium and drop it into water, we have this vigorous reaction taking place. Okay, we see light, probably heat, so therefore it's a chemical reaction. All right, so again, that was period 1, representing the alkali metals. The next group we're going to look at is group 2, which are the alkaline earth metals. All right. So the alkaline earth metals, these are group 2. They are not as reactive as the alkali metals. So early chemists thought that anything that was insoluble in water and unchanged by heat was one of the earth elements, and that is why these are called the alkaline earth metals. So these are again found group 2 right here. So they include beryllium, which is Be, magnesium Mg, calcium Ca, strontium Sr, barium Ba, and radium Ra. And again, notice it's always a capital letter first, followed by the lowercase letter. All right, next we're going to talk about the noble gases. These are all the way at group 18 right here. Those are the noble gases. So these noble gases, they are unreactive. And the reason why they're unreactive is because they are very stable chemically. They don't have electrons that are ready to form compounds. So examples of how noble gases are used, they are used, for example, for modern light bulbs. They may be filled with argon gas, which is a noble gas, and it's a very unreactive gas. They don't have any of those unpaired electrons, so they are unlikely to take part in a chemical change. So here we have helium, neon, argon, krypton, xenon, and radon. Our last chemical family that we're going to talk about are the halogens, and these are group 17. Right, so group 17 here, these are the halogens shown in green. So these ones react, they react very vigorously with almost every other element. They're naturally found in the form of compounds. So fluorine, chlorine, bromine, iodine, and astatine. They're very reactive halogens. And the reason being is they have an unpaired electron, just like we saw with the alkali metals. All right. Also, they're extremely corrosive and harmful. And there are lots of common uses for halogen compounds. So for example, fluorine is found in toothpastes and in some city water supplies. And it's important to help prevent decay by making tooth enamel stronger and more resistant to decay. Chlorine also reacts with sodium. Sodium was an alkali metal. So those two react together to form salt, table salt that we use day to day. All right, so just again, looking at the periods here. So group 1 that you guys are required to know, that was the alkali metals. Group 2, alkaline earth metals. Group 17, those are the halogens. And then group 18, those are the noble gases. All right, and then again, here is that staircase that I was talking about before. To the left of the staircase are our metals, and to the right of the staircase are the nonmetals. All right, and here again is another figure here, just again showing those chemical families or groups that we just talked about. So they're all labeled here: alkali metals, alkaline earth metals, halogens, noble gases, nonmetals, metalloids, and then metals. All right, so we're going to pause here and watch this quick video. After the videos, we will do this activity, symbols for elements. This is the activity I was talking about in the textbook, page 117.